All right, welcome everyone. Thanks for joining us today. I'm Emily Timty and I'll be facilitating today's webinar. During today's presentation, attendees will be in listen-only mode. If you experience technical problems, please use the questions pane of the GoToWebinar control panel. I'll be monitoring that area, especially during the start of our presentation today, so I can offer assistance if you need it. You may also use the questions pane at any time during today's presentation to ask questions you may have during the talk. Remember that your questions will not be addressed until the end of the presentation. And since we do have two presenters today, we will break up the questions, so there will be some time for the first presenter at the end of his presentation, then as well as after the second. So first we have Keith Eggleston today. And Keith Eggleston is the Regional Climatologist with the Northeast Regional Climate Center at Cornell University. He has been working for the Climate Center since 1982 when he was hired as the original Climate Center employee. His current duties include managing the NRCC's Climate Services Program and designing and developing climate information products for the Applied Climate Information System, or ACIS, such as xmACIS and NOWData. He is also the lead RCC contact for ThreadEx and Datzilla and serves as a member of the National Climate Data Stewardship team. So Keith, whenever you're ready.
Okay, thank you, Emily. I take some time here to show you some of the products and tools that we have available here at the Northeast Regional Climate Center. And for the Regional Climate Centers, the Northeast extends from Maine through West Virginia, as shown on the map in the bottom right corner of the title slide here. The main system behind most of our products and tools that we have available is ACIS. And ACIS stands for the Applied Climate Information System. It's made up of a database that has a lot of the traditional NOAA data sources like GHCN Daily, and also a lot of non-NOAA climate data, which makes it a little more unique. In addition to the database, we have a lot of products that we have developed that are built on top of the database. And we have a robust and efficient infrastructure for providing the climate data. We have redundant climate data servers at all of the regional climate centers. So if one goes down, we have several backups spread across the country. And a lot of our interfaces like xmACIS are now housed on Amazon servers. So again, we have redundancy around the country. Just to tell you a little bit of what's in ACIS, we have the GHCN Daily data, which is the main national database housed at the National Centers for Environmental Information. Also, several years ago, I checked around with a lot of the National Weather Services and offices and tried to acquire some of the data that was held locally that wasn't part of the national database. So we got quite a few contributions there, added them to the ACIS database, so that's unique. We also have some unique RCC networks that we have in ACIS that aren't part of GHCN. Like here at the Northeast, we have the Climate Record Books data, which was some key data that serves to extend a lot of the first order stations record back farther in time than are available in GHCN. We also have real-time data capture, which is something else that isn't available in GHCN Daily. Every day we get the chef encoded messages from WeatherCoder and the RTPs, add them to the database, as well as the CF6 data that you guys put out. In addition to the station data, which is pretty popular, we also have some gridded data that we have developed recently. There's some gridded daily temperature and precipitation data sets that we developed here at the Northeast Center. There's also PRISM, which is quite popular with USDA, does pretty well in more mountainous topology than just regular interpolated data. And if you want to look at some projections into the future, we have both LOCA and NARCAP to fill that niche. So probably a lot of you, I would think, would be familiar with xmACIS, with a lot of the products that we have available there. We have data for the co-op stations, the first order stations, and the ThreadEx stations. There's one product in particular that I wanted to highlight, which I'm not sure if you're making use of or not. A lot of times in the past, if you wanted to do a ranking of, say, the summer precipitation for a particular station, you might go into the extremes program. If you wanted to look at summer, you figure that summer is 92 days long, so you type that in, restrict your date range to June 1st to August 31st, and would get a summary like this. That will give you some results, but there's a lot better way of doing it than doing it this way. So I want you to shy away from doing that and instead use the seasonal time series product. In here, all you have to do is click on the season that you want, click summer, hit go, and then you've got your summary. So a lot quicker and easier to set up. The program runs a lot faster, and you don't have to worry about the problems that you would have with the other product during leap year and how to deal with leap day. That's all built into the program here. You just click on the total precipitation column, and it will sort it from lowest to highest. So if you want to do seasonal rankings, I suggest taking a look at the seasonal time series product. If you've used xmACIS very much, you've probably also taken a look at some of the graphic products that we have. The accumulated precipitation product shown here, and also the temperature graphs. There's one other fairly new graphic product. It's the multi-station graphs. In this, you can pick your product that you want. In this particular example, I'm looking at accumulated precipitation departure from normal, and then you can click off stations that you want to add to the graph. Here I just grabbed 4 stations along the northeast coast to show how the drought developed this past summer and how we're starting to come out of it now, and how that's changed across those 4 different stations. So you can, it's pretty nice to be able to compare different stations. Here's another one where I'm looking at accumulated snowfall for the winter of 2014-15 compared to 2015-2016, and you can see that for those 3 stations there's quite a big spread in the first winter, and then a much smaller spread in the second winter, with the totals actually pretty close to each other. That's another way that you could use these multi-station graphs. So it might be a product, if you haven't looked at it yet, you might want to look at that a little more closely. Also, on a lot of the multi-station products that we have, there's a map feature. I'm not sure how much you might have used that. It's kind of hidden a little bit in their interface. But you can, of course, get a listing of stations like this, which is helpful, but you can also get that same data plotted on a Google map. And then you can do everything that you usually do with a Google map, with zooming and panning and so on. So a good way to take a look at the data that you might not have seen before in xmACIS. In xmACIS and in NOWData, we have a station list for each office. We don't normally update those ourselves, but you can ask us to update them at any time upon request. If there are stations that you want to pull out of your list, or if there are new ones that you would like have added to it for your xmACIS list, if you'd like to reorder the stations in the list, we can take care of that for you. You can send me an email directly. You can go through your CSPM, or if you want to kind of keep track of how the ticket is progressing, you can put a ticket into Datzilla, and you can make any changes that you'd like to your station list. I usually update those about once a month. So let me know if you'd like to make any changes to make it more useful to you and more useful in NOWData for the general public. Quite a few people have asked me about who is allowed or to use xmACIS. xmACIS development was funded by the National Weather Service, so it's intended to be used by the National Weather Service only. If you do a Google search on it or anything, it shows up, so people can certainly get in there if they want to, but we ask you not to proliferate the URL out there. we want to keep the use by the general public as low as possible so that you will have as quick a response as you can get on xmACIS and not have it bogged down by requests from the general public. Use becomes too high, we might have to restrict it again by UR or by IP address like we did before, but we'd like not to do that. So it's intended mainly for National Weather Service use. There are other products that are available for the general public. There's, of course, NOWData, which is available off all your pages. It is a little bit limited. It doesn't have everything that xmACIS does. So there are two other options. There's ClimOD, which has a lot of the products in xmACIS. It does have data available for all the stations across the country. The interface is a little bit simpler, so it's good for the general public. It would be good for your media partners, I think. But if you do have some power users that really need everything that you can get in xmACIS, you can send them to another product called SCACIS, and they are free to use that as much as they want to. That's free and open. On my closing slide, I'll have the URL for these two sites, so you can hand that out to your partners if you want to. If you want to write your own programs using ACIS Web Servers, we have data for all the single station data access routines. We have the multi-station access routines. You can get to the metadata. You can get to the gridded data. Everything that is available through ACIS, you can get to through ACIS Web Services, and we're more than happy to let you write your own programs to access the data. The programs can be written in JavaScript or Python, Perl, PHP, just about anything that can make web calls. And it is all documented with quite a bit of examples at www.rcc-acis.org. And we do have quite a few people within the Weather Service that have written programs for use, both in just in their own offices, or I think they've also used them to develop some web products. If you do need any help getting started, you can feel free to contact me, and I'll help you get going on a program if you'd like to try to access the ACIS Web Services. Another product that we have that's quite popular is ThreadEx. That's been around for a while now. Just this year, we added ThreadEx Phase 2, we're calling it, where we added 50 new stations from around the country. So expanded the coverage quite a bit. In the next year, we're planning to add an additional 50 stations. You should be hearing from your regions or from NWS headquarters about nominations to have stations added to ThreadEx. And we also completely redid the website this year. Example screenshots on this slide here. Another place where we have a lot of products and tools available is on our webpage. It's www.nrcc.cornell.edu. Along the menu on the left here, there are quite a few options there for products that are available. Probably especially under state and regional analyses, you would find a lot of things that you might find useful. There are links to our state map products. We have every state in our region covered with monthly maps that are updated shortly after the end of each month. We also have daily updated maps from our gridded data sets. They're usually available by about 1 o'clock or so using the 12Z apps from that day. At the end of the month, we also put up summary tables where you can get departures and rankings for temperature and precipitation, as well as degree days and some drought indices for each state in our region. If you click on a state like I did here for West Virginia, it will give you a breakdown of the ranking and departure for every climate division in that state with a little map to show you where the divisions are in case you're not familiar with that. And this summer, this past summer, during the drought, we instituted a weekly drought update that was posted on our website every Thursday just after the U.S. Drought Monitor maps came out. It had a lot of our own maps and information on water resources and stream flow and so on to help people monitor the drought. It was updated every week. Now that drought has been wiped out of the Northeast, it won't be updated as often this summer unless drought comes up again. We have a lot of other gridded map products, things that are a little bit out of the mainstream. We have growing degree days used a lot by agriculture. Also for agriculture, 2-inch soil temperatures based on a model that we developed here at the Northeast Regional Climate Center. And this is recommendations for seed head control, which we put out to turfgrass managers every spring to help them in their spraying. And another network of weather stations that we have is called NEWA. It's Network for Environmental and Weather Applications. We have a lot of decision support tools in there for farmers. This one is for fire blight, which is a disease on apples. It takes information from the weather stations as well as the forecast from NDFD and puts out recommendations on the status of that disease and whether or not the farmer should be spraying to control it or not. And here's another similar one for another agricultural pest, the cabbage maggot. And again, the days that are highlighted in red there are days that they should be spraying to control this particular pest. So those are a couple of the decision support tools that we have for agriculture, for farmers in the Northeast. So here's a list of some of the products that I referred to. The first one is our web page. Then there's Climate 2, which is something you can hand out to the general public. xmACIS, which is the same URL as xmACIS, except you replace the XM with an SC. You can get that out to your users if you want to. And then there's the newly updated ThreadEx website, which you can play around there. That's also generally available to the general public as well. So I think I've left some time here for questions if anybody has any.
Okay, yeah, so a reminder to everyone that if you'd like to ask questions for Keith, to please do so now through the questions pane of the GoToWebinar control panel. So we'll take questions before we pass it on to our next presenter, so please feel free to enter them now. So we did just have one comment just saying that the preferred method of requesting sites is to go through the Regional Climate Services Program Manager within the Weather Service. So that was just a comment for clarification. So
yeah, it varies a little bit by region. I think in the central region, they like the request to go through Datzilla.
Okay. Okay, I have not seen any questions yet, so if anyone has one, please shoot one in there real quick before we switch over. Okay, we did have one question just come in. Is there a real-time data service for hourly precip data?
For hourly precip, we are just testing now our hourly web services, so we are working with hourly data a little bit. So for some of the networks of weather stations that we maintain, there is some hourly precipitation. From tipping buckets, it's not that great, not that great quality, but we also, for the first order stations, have the hourly data from the ASA. So we do have that hourly data. We don't have the hourly data from the Fisher-Porter rain gauges. That isn't available yet.
Okay, great, thanks. So it looks like that's all the questions we have right now for you, Keith. So thank you very much for joining us today and giving your presentation for the NRCC.
Okay.
So at this time, we're going to switch presenters, and we are going to shift it to Chip Konrad, who is with the Southeast Regional Climate Center. So Chip Konrad is the director of the NOAA-funded Southeast Regional Climate Center. He is also an associate professor in the geography department at UNC-Chapel Hill. He has expertise across a wide range of areas in applied and synoptic climatology, including heavy precipitation, tornadoes, hurricanes, cold air outbreaks, and winter weather. He has published numerous research articles in various scientific journals, including Monthly Weather Review, Weather and Forecasting, the International Journal of Climatology, Climate Research, and Applied Geography. He was also a co-author on the Southeast Technical Report for the National Climate Assessment. So Chip, if you're ready, you can take it away.
All right, thank you very much. Before I get started, I wanted to recognize a few people here in our office. William Schmitz is the service climatologist, so he's available. You can call him up, send him an email, but he's there with to answer a wide range of different requests. Also, Jordan McLeod, he's our regional climatologist, so he's the primary person who really works on the development of various climate products, some of which I'm going to show you here in this presentation. And finally, we have Ashley Ward, who actually, she sits here at the Southeast Regional Climate Center. She's funded by CISA, and I'll tell you a little bit about them here in a second. But she's a climate outreach and integration specialist. So here in this talk, I'm going to kind of provide a sort of a broader perspective first on the regional climate centers, and so I think this will be a nice complement to what Keith's talk, where he really focused on the products. So I'll say a little bit about basically our functions here at the SERCC, what we do. And I'm going to say some things about some of our ongoing research activities and really talk a little bit about how they might connect with the National Weather Service, particularly in regards to heat illness. And then I'll mention some of the monthly and quarterly climate reports that we author for the region. And then lastly, I'm going to show you some of our products and tools. I'm going to focus on two of them, Climate Perspectives, which I think some of you are probably aware of, and also a web-based heat health vulnerability tool. So just to start off, and I know some of you are probably very familiar with this, but in case you aren't, there's 6 regional climate centers scattered out across the country, and you can see the footprints here in the map. And so our region extends from Virginia to Florida. There's always been the question about the District of Columbia, and I always tell Art up at the Northeast Center that we actually have DC proper, but anyway, basically we go up there into the up into the DC area. So basically, we're really a hub for climate services, monitoring, research, and education in the Southeast. We've been around for a long time. The centers more than 28 years, at least for some of the regions, and so we really have a deep knowledge of basically climate service and really tailoring that to a wide range of different stakeholders. And so I don't know, so this is a nice little diagram here that kind of summarizes what we do. And so a lot of this is we're really kind of at the intersection of education, engagement, data, and of course Keith told you a lot about that. And so we have this ACIS system that Keith talked about, where a lot of what we do ultimately is taking climate data and tailoring it to a wide range of different needs. And so basically translating data to information. And so part of doing this, of course, involves applied research that we carry out to really try to identify all the different ways weather and climate variability and extremes, how they impact different sectors of the economy. And so this can be very particularized, say around a particular crop. And when you get any sort of climate anomalies, what does that mean in terms of the growth of the crop, or maybe the application of fertilizer, that sort of thing. So we do a number of different things, but a lot of this is really overlapped or intersected, and that's what I think is really useful there. When we talk about service here, just a couple of things about what that really means. The first bullet here, a lot of this involves really direct interaction engagement with climate stakeholders. So, we take the time to go out and actually meet with them and learn more about what is it they really need. We learn a little bit about their business, and so we learn about the different ways in which they're sensitive to climate and weather extremes. We also, of course, handle the distribution of accurate and unbiased climate data, data products, and information. And as I said, we carry out applied research. And then lastly there, we do a lot of education for different stakeholders. Okay, so I'm going to pretty much skip this slide here, but really the foundation of what we do is really based on this Applied Climate Information System, ACIS. And so Keith provided a whole lot of detail on ACIS. And ACIS is just a really good platform for building a wide range of tailored web-based products. And one of them I'm going to show you here in this short talk is Climate Perspectives. And so I'll go into that. So we have a number of partnerships, and so I think it's really important to mention that. Here at the Southeast Regional Climate Center, we're really tied to the hip with the Carolinas Integrated Science and Assessments Program. So they're one of what I think now are 9 RISAs, Regional Integrated Science and Assessments programs across the country that really work a lot with communities in terms of identifying vulnerabilities to extremes and determining ways in which these communities can be more resilient. We also work closely with the National Center for Environmental Research, NCEI. You might remember this here as NCDC, the National Climate Data Center. So there was, of course, that merger that happened a couple of years ago. And we also connect with National Weather Service offices in our region. We work closely with the state climatologists in our area, particularly North Carolina. Our information technology, our IT, is basically handled by their office. But we have a monthly phone call with the state climatologists. That helps keep us abreast of really what's going on there. Okay, so I'm going to tell you a little bit about a few projects that we're on, that we've been working on, and one is we've been engaged in this in a long time, looking at heat and health vulnerability here in North Carolina. And the research here, I think, greatly informs the National Weather Service, the heat advisories and warnings that are issued. Okay, and I just want to this is kind of a show and tell, but I wanted to put up a map here of North Carolina. And one thing this research showed is that when you drill down, and this is drilled down to the zip code level, you find a lot of variability in the vulnerability of people to heat. And so this presents here basically the number of people going to the emergency room due to heat, and it's basically divided by the population. So it's basically a per capita measure. And what really stands out is there's tremendous variability, and there's nearly an 8-fold difference between the areas in which it's low, which is in the blue, to areas in which it's really high, which is the red. And of course, you can see across this variability here that generally in the mountains it's low, it's relatively high getting into the coastal plain. Of course, that partly reflects the fact that it's somewhat warmer in the coastal plain. But what this really shows more than anything is that some people are a lot more exposed, and so in areas where there's a lot of people are employed outdoors. So in agriculture in particular, there's a lot more people outdoors. You get big increases in the amount of heat illness. And there are a couple of areas down here in the coastal plain of North Carolina, a lot of agriculture and very, very high rates of heat illness. This plot here basically shows how many people go to the emergency room according to the daily maximum temperature. And this is summed up over the course of the entire summer. Summer here defined by May through September. You can see it's very low. Obviously, when it's cool, it increases greatly with increasing temperature. But interestingly, what you find is it peaks in the low 90s, and then it goes down quite a bit after that. You might wonder, why does it go down? Well, this is added up over the entire heat season. And so here in North Carolina, there are just a lot more days in which the temperature is in the low to mid 90s. And so this peak here just simply reflects that there's a lot more of those days. But just seasonal, temperatures that are seasonal in this area lead to high numbers of visits. And so that's very significant. I want to show you here a slightly different plot. This plots how many people go to the emergency room on a per day basis based on maximum temperature. So if you just take a single day, and we're going to look at the heat index here, take a single day, we find that when the temperature gets up above, this is the heat index, above 100, it's really going up, and it basically peaks around 108, 109 degrees, and then it really goes down after that. So what this says here is that once the heat index gets certainly past 110, you see a huge reduction. And so what we hypothesize here is that people are actually heeding the warnings that the National Weather Service is putting out. That's part of it. And also, too, people just simply know, it's so hot out, and so they basically reduce or completely curtail their outdoor activities. But anyway, this research basically sets things up so that we can build tools that translate predictions of temperatures, say by the National Weather Service, into basically predictions into how many people will go to the emergency room. And so I'll say more about that here in a second. Just real quickly, this plot here just shows that there's huge differences between metropolitan or highly urbanized areas indicated by the red, where the rates are much lower than what they are in rural and isolated areas, as you see here in the green. So there's a very prominent geography here. Another study we're looking at, and I don't really have time to go into it, but we're looking at how gastrointestinal illness varies with heavy rainfall. And we had a master's student here who did some research that showed that there's certain areas, you see them indicated there in the blue, these blue counties, where there is a marked increase in the number of people going to the emergency room after it rains a lot. And I think this was on the order of, and it wasn't a very high threshold, on the order of 2 or 3 inches in a single day. And that's not to say that every time it rains a lot that there's a huge increase, but it's something very interesting, and we're digging into it a lot more. And what we're finding with this research is it's very, very complicated. There's obviously a number of reasons people can get GI illness. So it's a real complicated thing, and we're just starting to get into that. So skipping over here then, one of the things that we put out, and also the Northeast Regional Center puts out, are these monthly and quarterly climate reports. And so I just show an example here from last summer. So basically this provides basically a summary of what the summer conditions were like, starting with a graphic of the anomalies that existed sort of meteorologically in terms of circulation, and basically showing how they varied across the Southeast, and basically focusing on the impacts and then giving sort of a short outlook for the fall. So that's just one example. If you go to our website, and I don't have time to show it right now, but you can find these for the current period, and then there's an archive that goes back in time. Okay, so I want to show you 2 tools here in the remaining time I have left pretty quickly. The first one here is called Climate Perspectives, and we have 2 versions of it. One of them we run for the Southeast U.S. and another one for the continental U.S. And for the Southeast U.S., basically it provides a perspective on the climate for basically, for really most stations that exist here. So this is stations in the Cooperative Observer Network, and also, of course, the Order 1 stations with the National Weather Service. And so what this basically does is it provides an assessment of the ongoing and recent state of the climate across many stations. And in this way, it provides a sort of basically a fluid perspective on the magnitude of temperature and precipitation anomalies across different periods. And you can use it to find, among other things, the closest historical analogs to a given weather or climate event. So just to kind of give you an example of it, I pulled this. This is from a presentation I gave last year. So this is a climate perspective that's produced for Raleigh, North Carolina on a particular day. And so this is updated actually several times a day. But starting here with Saturday, August 13th, it gives you what the max and the min were. This is an exceptionally warm day, as you can see here, especially for the minimum temperature, only getting down to 77, and it kind of tells you how it departed from the 30-year average. So this is nearly 8 degrees above normal for the min. So for that time of the year, that's really impressive. That actually tied for the first warmest in a threaded record going all the way back to 1887. And putting both of those together, that is most equivalent to Houston, Texas, in terms of the max and the min. And really some of the power of this is that you can look through this table here and you can kind of pick out periods that really stand out. So that the particular day of interest, the last 2 days, the last week, etc., going up to the past month, all the way up to the past 6 months, year to date, even going back to basically the past 2 years. And I'm actually literally going to go to Climate Perspectives here, and I can show you that. Let's see. going to pop that up. And so I came up here on the fly just with the climate perspective for Washington Reagan Airport. Okay, and so this is up through yesterday. And you can see it was quite warm by Washington standards. It got up to 85, 6 degrees above normal, a low of 64, so that translates to equivalent of Birmingham, Alabama. So this is something that's very useful for the media. They can say if something was really unusual, they can kind of give the audience of what it was equivalent to geographically speaking. But scanning down through here, you can really see what stands out the most. And for example, if we look at average temperatures, kind of scanning down through here over these longer and longer time periods, what we see really standing out is going down here to the past year and the past 2 years. So for the past year, the average temperature was nearly 62 degrees, 3.6 degrees above normal. That tied for the first warmest for a record going back to 1929. And for the past 2 years, you can see that it was truly the warmest over that time period at 61.3. And basically what you can say in terms of temperatures is it's really equivalent to Norfolk, Virginia. And so if you look at that on a map, what is that, like 200 miles? 200 miles to the south-southeast. That's, and that's how much, basically, how much warmer it was. Okay, and so I want to give you another perspective here. This can also be done for the continental United States. And here, and I don't have time to go in to show you exactly how to use the tool, but you can pick your variable here. So I picked total precipitation. I want to present it in terms of a total. I picked the other day, Sunday, as the end date, and then I picked a period of 3 months. And so if we click here, I could pick, this particular day, the past 2 days. But I just picked the last 3 months. I wanted to show them in here in terms of ranking, so you see them here. And so then I basically, click here, show perspectives, and so it takes a second here and it runs. And so here you can see, and this is really for the first order National Weather Service stations across the country. You can see here the ones in the green really stand out. So anywhere from basically being the wettest over the last 3 months to the 10th wettest. And so you see over a broad part of the country, there's a number of stations that have been exceptionally wet. So there's lots of different climate statistics that you can get out of this tool here. So going back here, so let me finish up, and I want to show you one other tool that we've been developing. It's called the Heat Health Vulnerability Tool, and basically this tool inputs National Weather Service gridded maximum temperature forecasts and translates these values into predictions of the number of people that are going to go to the emergency room due to heat illness. And it's simplified a little bit, that it basically distinguishes between rural and urban areas. That was the first version of the tool, and recently we came up with a new version that works with the daily maximum heat index. And so there we work with the greatest 3-hourly National Weather Service forecast, at least out to 3 days. After that, it's something that we had to estimate, because that's not a product that the National Weather Service currently provides. And so this is an example here. This is a case that we did last year. So basically you go up here and you select your county. So I selected Bladen County, which is one of those counties in North Carolina that has high rates. You can choose between rural and urban. So we pick the rural part of Bladen County, and I think just about all of it's really rural. And then it defaults to the current date that when the user is using it. And so here basically it provides a perspective on how many people go to the emergency room on the basis of basically a baseline around 100. And so this blue line here is the prediction. This is the baseline. And anytime it goes above the baseline, you see more visits than average. And so if we see this here, we see this particular peak. This corresponds, if we look over here, more than 300%. So basically more than 3 times the number of people going to the emergency room than what you would normally expect there. And just very specifically, it provides a perspective over the past 2 weeks, and then it has a forecast going to the next 5 days. And again, this forecast is based on National Weather Service forecast of the maximum 3-hour heat index or whatever. So, okay, and so I think I'm about out of time, so I'm going to stop there. So I guess there's a little bit of time here for questions.
Yeah, we definitely have time for questions. So if you have any for Chip, please enter them in the questions pane of the GoToWebinar control panel. So I'll be monitoring that area over the next few minutes to take any questions that you guys have. I was just going to comment that the heat tools you have are really interesting. Are you guys planning to expand that to any other states?
Yeah, that's a really good question. And you know, one thing we found here in North Carolina, and I illustrated it there, is that the relationship between heat and how many people go to the emergency room varies a lot. And so we're hesitant to extrapolate the relationships we've developed in North Carolina to other states. But what we would like to do is to get health data from other states and basically, you know, identify what those relationships are. And then once we have those relationships, then of course we can expand the tool. One of the big challenges, of course, is just getting the health data. And there, you know, there's some localities sometimes that don't report. We get incomplete reports or whatever. But it's like anything. Once you dig into it, there's a lot of things that you have to, you know, that you have to deal with.
Yeah, very cool. So yeah, if anyone has any questions, I don't see any coming in right now, but we'll give it another few seconds to see if anyone has any last-minute questions coming in. But yeah, I think that tool is something I hadn't really seen before, and it's great, especially with all the heat-related illnesses we've seen over the past several years.
And yeah, and as we're waiting here, I'll just show you. You know, I basically put up the tool here. You know what it looks like right now. We've simplified a little bit because in our engagements with public health people, they were a bit confused in the way that it looked. So we simplified it a lot. But here you can see you can pop in your county, and so if I put Bladen County here, put in rural. So we've got the current date, you know, today, May 30th. So it defaults to that, and so you just simply hit go there, and so then here you get this perspective. You know, how many people are expected to visit, and you know, fortunately, if we look back in the past, we can see it's a bit below normal. It went above normal a bit, and we go up to the current day where it's very close to normal. And we see coming up, it's going to be very close to normal. So we're going to have temperatures or heat indices that are very close to normal for this time of the year. And you can actually see that here. So this provides a presentation of the daily maximum heat index going back over the last 2 weeks, and then going forward over the next 5 days.
Great. So we did have a question come in. I think they're related. They said, how can I find the rest of the U.S. stats on this page? So I'm assuming they're referring to the heat illness stuff that you were just discussing again. So. Yeah,
so to this point, our heat work has been confined to North Carolina, and we want to expand it to other states, but we're just, you know, we're not there yet. And so for this kind of tool here, you know, it would be great to be able to have this, you know, to increase the geographical footprint, you know, the area that, you know, that you can, where you can get this information.
Okay, and is the heat tool open or available to everyone?
It is, and so, and you can see it right here. If you just go to convergence at unc.edu, and I will pop this up so you can actually see it. So just remember convergence, unc.edu. And we just go to tools here, and this is the first tool that we have on this website. Okay, and so I just click on the tool, and there you see it. And again, you just put in your county here, select a model, whether, you know, it's a rural or an urban area, and then you just hit go. It looks like something, I don't know what happened there, but it looks like that's interesting. So I'll have to look and see what's going on there. It's an ugly looking formula.
Yeah. Okay, thanks for them. We just had one other comment and just said both presentations were really great. So yeah, with that, it doesn't look like we have any other additional questions, but if anyone does have questions after the fact, you can email me and I can direct them to either of the presenters. So thank you, Chip, and also thank you to Keith for giving this presentation today. Give us a few days and we'll have the materials from the seminar, including the recording, posted online. So thanks again for everyone's participation, and thank you to both of the presenters today. Have a good one.